Okay, yesterday we just finished up going through calcium, and when you look at calcium, it's in the fourth row across, or fourth period. And so when you look at kind of comparing a drawing of the Bohr's model, where these electrons are located in the regions, you've got 2 electrons in the first region, you've got 8 electrons possible in the second, you got 18 in the third, and then you've got 32 available in the fourth, when you take a look at how many each level can hold. So when we do calcium, calcium is element 20. We finished that up yesterday. So when you go through and fill in your levels and sublevels, they go 1s is filled first, then 2s, 2p, then 3s, 3p, and then a person would think, well, calcium should be next and it should go into D's, but it will not. I think we discussed that a little bit yesterday. And then the fourth level, you got 4 S's, 4 P's, 4 D's, and 4 F's. So that's the levels in which they go in, okay? So that S's can hold 2, of course. They're maxed out. P's can hold 6. They're maxed out for that. The D's can hold 10. And the F's can have 14. So when we do calcium, number 20, we got the 1s2. Okay, and there we got, right there's 2s2. And when we got 2s2, 2p6, that would be 2s2, 2p6. So the second level is full. Third level can hold 18, so you go 3s2, that would be one of them. And you got 3p6, that would be also in the second level. And then what happens is the 4s is filled before the 3d. And the reason why is because their energies are fairly close together. And what happens is we find out later on that a 4s is less energy for the electron to be there than a 3d. So electrons are lazy and they pick the lowest energy level available. So that's why it's 4s2 for calcium. Okay? So calcium, when we do the shorthand, we start with the noble gas above it. Remember, it was argon, and it's 4s2. Now what we're going to do is we're going to add a line underneath, and that line represents the orbitals where the electrons can be. And each orbital can hold 2 electrons. So each orbital, since S only has 1 orbital associated with it, that's why it's filled. And that would be the that's called the orbital notation. And it just gives you a little bit better idea where the electrons are at and how they're paired. Okay, so we might as well go into doing one in the D's as long as while we're doing it. Okay, so we're going to go ahead and do one in the D's just to kind of see where that all kind of figures in. So we're not going to do calcium now. So let's go ahead and we're going to do cobalt. Cobalt is number 27. Okay, so I'm going to do the shorthand, and then so we're going to go ahead and still use argon as our starting point. So we'll call the noble gas configuration. We start with argon. That's just a different starting point. So then we've done argon is through, these have already been filled in for argon. Okay, so there's argon. Those have already been filled in. So then what we'll do is we remember the 4s is less energy than 3d, so we'll go 4s2. That's been filled. And then we can go back to the d's, and we'll go 3d, because these d's have not been filled. A lot of times students will make a mistake and they'll start filling these 4d's. And so they'll go 4s2, 4d. They can't do that, all right? Don't want to do that. So what you'll do is just do the 3d's. But you're going to count over. And so you use your periodic table as a guide. And you start with scandium, which is 21. And so scandium 21 over to cobalt, which is 27. That's 7. So that'd be 3d7. And then if you do the lines underneath, S is full. So orbital notation for that is full. And the D's have 5 possible orbitals. So if you want to know how many orbitals each has, S's have 1, P's have 3, D's have 5 possible orbitals, and F has 7. So we fill them in one at a time. Okay. There's a rule, Hund's rule, says you need to fill them in one at a time, and then once they're filled in at least once for each orbital, then you go back, excuse me, and pair them back up. So that would be the configuration for cobalt. All right. Now the last thing is, what if we get in the F's? Okay, the F's come in these 32. So we have S's here, SP's here, SPD's, and SPDF. So the F's will come in the fourth. So we're going to do one where we go through the F's. Right? And I'm not going to show the circles and that, but we'll just pick up where we left off. Okay, and we'll use this one as an example of what we did. So I'm going to do a little erasing here. Okay, so we're going to do one that goes through the F's, and we're going to pick osmium. Osmium's element 76. So we look to see where osmium's at. It's in the 6th period. We're going to pick xenon out. Now xenon's in the 5th period. So we'll go xenon. Okay, so then xenon, what have we went through up to that point? Okay, so these will all be inner shell electrons. These are called inner shell electrons at this point. Okay, so those are the ones that have been eliminated if you would go through the sequence and put them in. Alright, so then osmium's on the 6th period. So then we're at cesium and barium, which is right here. So that goes through barium. So then we go 6s2. So that's been eliminated. Okay? Now, if you notice, there's a big gap. It goes 57 to 72. Well, if you look 57 to 72, there's a big gap down below, and it goes 58 to 71 in that row across. If you count across that row, there's 14 elements, and those are the Fs. So the lanthanide series, those are the Fs. And so, since we haven't done Fs yet, if you notice up here, we have not done Fs. So, fourth level, right here, we start doing our Fs. So we go through all the Fs, and it's 4F14. And so we're at the end of the Fs, and then we start at element, kind of like element 57, and going across and starting there and counting our 10. So we got to count, including lanthanum, we're going to count over how many it would take. So 1, 2, 3, 4, 5, 6. So osmium is going to be 6. So the 4 Fs are taken. Alright, so then we're in the D section. If you notice, we've already taken the 4 Ds, but the 5 Ds have not been taken, so that's going to be 5D6. Okay? And so then that would be the electron configuration for osmium. So it gets a little bit confusing when you do get the Fs. Just remember the Ds are always one level lower than the S's when they start filling in. And the Fs are 2 levels lower than the S's. So here's the 6 S's. And if you have Fs and you go through one of those bottom rows, it's always going to be 2 lower. Okay? And then so we did last year, we didn't go through Fs or in the past. But now that you've been able to do it and take a look at it, that would take you through the Fs. So I want you to go ahead. We're going to just give you a variety of ones to do on your periodic table. So, the variety of ones we're going to have you do on your assignment, and some of them are really easy with the shorthand method, and some of them are a little bit more drawn out. So, but that's okay. You can handle that. So, we're going to do selenium, and then next one we'll do is strontium. Okay. Let's do bismuth. That's going to be the tough one. Bismuth is going to be the tough one, but you guys can handle it. We're going to do zirconium, silicon, and one more. Let's do bromine. So do the electron configuration and orbital notation. So orbitals are with the lines, and then electron configuration.